executed lots of times. So let's look now at what we're going to do about the iterator. Well, we're going to override a method called iterator in array iterator. Well, no, that's not what we do at all. Look what we do here. We are going to, when somebody asks us to give them an iterator, we're going to return back something of type iterator. To do that, we're going to create a new array iterator. This is something we now have created a class to represent. This array iterator implements iterator, which is why we can return it as an iterator. And it allows us to use the iterator inside of the linked list, the Java iterator, to get an iterator, which we then rewrite the has next, the next, and the remove methods to call the iterator and same method. Now, why do you think we did it that way? Instead of just directly returning the array's iterator. This is when you need a long, pointy beard to be rubbing on while you're thinking about it. Xavier?
I'm doing the first so we could put in the remove function. We could put in an error.
That's exactly right. If we were to use the iterator from the array method, it has fully working, has next, next, and remove. Well, what did we say about remove? Doesn't exist inside of our interface. So even though we get an iterator back, when we're iterating, we have to make sure that the remove method can't be called because you can't change the size of our array. So all this was added just so we could override that method and still return, from doing most of the work for these two, we could use whatever the iterator inside of the linked list or the array list was doing for us. Very good. That's usually a hard one to answer. And that's the entire implementation. Not very much work to make that happen. So then, of course, the next thing we ask is, how do we test it? Well, we have a test folder with a test package. Notice it ends in test. We have some test code here. Now we'll talk about this for a second. Test IArray1, that way I can have multiples by numbering them, 2, 3, 4, 5, and things like that. Starts with a main. The main's just like our mains are. It initializes the class and calls doIt. Inside of doIt, we can do any testing we choose. So the first test we chose is to create a new implementation array of size 11, storing it, of course, in an interface array of integer called A. Now we want to go through from 0 to less than the size, bumping at the end each time. And we want to set each element, that's each index, to the square of the index. Now we want to go from 0 to the size, bumping it each time, printing whatever we get at that index. Of course, that thing needs to be turned into a string using the toString method of whatever we're storing inside the data. And added to it, we want to check if I is the last element. And if it is, we're going to stick in a new line. Otherwise, we're going to have put in a space. We could use join. We're just showing you a different way to do it. Then we're going to get an iterator on our array. And while the iterator has a next item, we're going to get that item. If it's equal to 25, we're going to put a try block up where we do a remove. And we do it this way because we know that's going to throw an exception. So we catch the exception. We print out the fact we had the exception, but that lets us continue. We can then print out in and continue back again. And finally, we use the for each construct. This is the one that requires us to have a for each method. And with this, we simply iterate our array, passing each in and printing it out. So I should be able to run this. I can go to the top, hit the run button. You never find that little thing. So here initially, we printed out on the same line all the numbers through the square of 0, square 1, square 2, square 3, all the way up to square 10. And we printed them out. When we got to the 25, we made sure the exception happened. We made 100. Then we did it again with the for each method. And all of those things seem to be hooked in properly. Now, what I normally do is I keep that test without changing it because that's the one the teacher gave me. I come over here, I right-click on the test. I say copy. I highlight the package. I right-click again, and I say paste. I check the name to make sure it bumped it up to 2, and I just add it. Now, I close all the windows I have open, and I open the second one. Now I can write any test I want to in here. Basically, I'm going to delete everything except where I initially create the array. And we could do a couple things there if we wanted to. We could test to see if we could create an array of size 0. We could test most anything we wanted to. But what I want to do is I want to stick some things inside of the array. So I can use the for loop again. So I can say for integer I equals 0, I is less than a dot size. All this stuff is testing code. Get size. See, I typed the wrong thing there, and it fixed it for me. I plus plus. Now I can say A is equal to, I don't know, we'll just make up 231 minus A. Now, what's wrong with the statement I just typed? Well, A is not anything other than it's just the array itself. That's not how you assign elements, remember? Normally we do square brackets, but what we're going to use is we're going to use A dot set. We're going to pass it an index, which is I in our case, and then we'll pass the 231 minus I in our case. Now, if I go to the top and hit save, and I wonder if I have any errors, I can come over here to problems, and I can look and see it says there's one warning. It says I'm not using that import yet. To get rid of that, I can push Control-Shift-O. And it'll reorganize these for me. And I can go over here and save again. Now this would run, but it's not going to do anything. So what I want to do is let's test to see if I said a.stream dot for each dot out colon print line. Let's see if that works. We can test that code. So if you're here, run. There's my number starting at 231 counting down. So that looks like that works. This is the for each on stream, which means the stream method we wrote works. We also have a for each method, right? We could just say a.for each. We could do the same thing, you know. System.out, print, colon, print line. This is the one we wrote that's on the interface. This is the one we wrote for the stream. So the stream we wrote, the for each we didn't have to. This for each we had to. And you could write your own tests. And I encourage you to write tests to see what works, what doesn't work. None of the classes we're building are going to have thorough error checking in them intentionally. And you'll find that occasionally something may be missing and you may want to try to understand why it is. Under no circumstances, unless I give you different code, change any of the ones that begin with an I. You can change your version of the implementation, but if I ever test and don't have your implementation, your code probably won't work. So the best place for you to make changes are test inside the test case. If you come up with something that doesn't work, pose it as a question of why this doesn't work and see if we can figure out what we forgot, what I might have omitted, what I may have put in there as a trap. I occasionally put traps in the code so if somebody copies on a test, I'll know. But I don't often point them out. And I also sometimes show you how to do things multiple ways. And some of the ways are not always the best way. It's just an alternative way to do something. For example, here's two different ways. If we went back to the first version, we had a way here where we printed it out. And I think down at the bottom, we had another way to print it out. All of those do the same thing. Okay, any questions about the IRA interface or its implementation? Okay. I think what I want to do now is talk about, well, this will sink in on you between now and then. What is today's date? Is today middle of the week or start of the week?
Middle.
Middle, so we're...
Wednesday.
Yeah, I don't see you guys again till Monday, do I? Maybe we won't do that today. Maybe we'll do some programming so I can give you a weekend programming assignment here. Okay, I'm going to close this. For now, I'm going to close the data structures project. I'm going to hit X down here. Now, you're going to want to do this with me up to a point today. I'll try to go slowly, and I know if you get behind, you'll have to take some notes. I will give you, probably some of the code, but you don't get as much out of it if you don't kind of work your way through it. So what I want to do is let's create a new Java project and call it Hello Swing, S-W-I-N-G with a capital S. Make sure you say don't create when it tries to create the module. And inside a source, we want to create a package. I'm going to call it edu.mccc.cos210.swing. Give me a green circle when you've gotten that far. If you missed out on how to use Eclipse and stuff like that, you'll have to catch up. I saw a couple people volunteered in the chat last time to help you. You may want to contact people if they're willing to help. Okay. So what we want to do is we want to put together kind of a model we would use anytime we wanted to write a swing program, just like we did with the Hello World, something we could start with. And that way, if we have something we need to do quickly, we'll all be following the same style guide and things. We won't have to invent stuff that probably we shouldn't be inventing. Now, as we go along, occasionally I'm going to type something and say, I'll tell you, don't type this. I'm going to type something and remove it when I'm done, just so you can see what happens. You don't have to follow every keystroke, but ultimately I want you to wind up with the same model that I do. So, right click on this. We want a new class. The class's name is going to be Hello Swing. We want to give it a main. Now, so that I'm likely to make mistakes, I'm doing this without notes, and that way I'll be able to explain to you as things need to be fixed. What we're going to do first is we need to, just like we would normally inside of main, create a environment that we can work in. So in the regular world, when we're doing programs that are not graphic initial or graphic oriented, we create an instance of the class so that the main thread stays hanging around. In this case, we're going to create a separate thread, which is called the AWT event thread, Abstract Windowing Toolkit event thread, on which all of Swing runs. Swing itself, which is the user interface kind of package that we'll be working with, is single threaded. And so we have to ensure that anything that happens for that thread happens for Swing happens on that thread. So instead of creating the main thread, in our case, we're just going to let the main thread fall off the end and end, but we'll have caused a different thread to have started. I'm going to put inside of main a function call, which will allow us to get on the other thread. To do that, inside the class event queue, I'm going to call a method called invoke later. And I'm going to pass to it a method reference to our constructor. Okay, now try to keep up with me. I know that's a lot of characters. Okay, now, in front of main, I'm going to put the constructor. I'm going to open up a couple lines to give me some room to work. So I'm going to have a public constructor, so there's no return type. Hello, Swing. Takes no parameter. It'll have a couple of lines of code in it. First thing we're going to do inside of this is we're going to create a JFrame by calling a method called init swing. And we're going to pass it, it's the words hello swing. Put some space between them, because that's going to appear in the title bar. I might as well make it look pretty. Now, I have a header I need to include, so Control-Shift-O the header in. And you'll notice that this is underlined because this method doesn't exist yet. So I'm going to write that method right in the space underneath. So public is going to return a JFrame, call it init swing, and it's going to take a string called title. Now, the reason this is underscored right now is because we're supposed to be returning a J-frame and we're not. So what we need to eventually do, last line of this is going to say return JF. We don't have a JF yet, but we're going to create one right now. We're going to say J-frame, not K-frame, J-frame. JF is equal to a new J-frame, we pass it the title. Now, we're going to have one variable up here that is underscored. And the only reason is it's warning us that we didn't use that anywhere. That's okay for now. So we're going to create a J-frame. We're going to return it. Once it comes back here, what we're going to do is we're going to make it visible. We're going to say JF.setVisible, true. Now, there shouldn't be any errors at this point. And if we go up and we hit the run key, which you can do, nothing really looks particularly visible on the screen other than see if I can. One of these is hard to get. I think it's this one. You're going to get a little window that looks like that. Give me a green circle if you got that little window. Yeah, that was right. Now, it turns out that this window, if you actually push on the center button there, it is resizable. But it basically is a J-frame that now we need to do some styling with. So I'm going to hit the X to close it. Notice when I hit the X, the red down here did not go out. The program is still running and the AWT event thread is still running. All we did when we hit the X was hide the window. So we need to do something about that. So what I'm going to do is in the init swing right after I create the J-frame, I say jf.set default close operation J-frame exit on close. Now hit that little red box to cause the other program to terminate. And then just rerun your program again. And when that little window comes up, which is this guy, then when you hit X, you'll see that the little red dot goes out. That'll cause the program to terminate when we hit the X key. Okay, now, we need to give it some size. We're going to write the wrong thing first, and we'll come back and fix this in a few minutes. We're going to say jf.set size. Whoops. And in here, we're going to put, let's put 800 by 600. Put a semicolon on the end of it. Rerun again. Should now come up with that correct size. It is, however, at this point, resizable. We don't want that. we're drawing something graphically, we're going to want to pretty much make that be a special case. So what I'm going to do now is I'm going to add a line that says JF, that's set resizable false. It's not resizable. Run it again. You bring it in, you'll notice these have been, this has been grayed out, and if you try to grab one of the sides, nothing happens. Hit the X to close it again. Okay, give me a green circle if you're caught up. Okay, next thing we need to do is, because our program is going to be used in this class and for testing and things like that, we're going to be rude. We're going to add a line which is extremely rude. It's going to say JF, set location relative to, we're going to put a null in parentheses. What that does is it's going to force our program to come up right in the middle of the screen. Normally you should let it come up where the window manager wants you to put it, but we're going to be rude and just jump to the middle of the screen, because anytime we run our program, it is the most important thing going on. Now I can't show that happen, but on my screen number one, it came up in the middle like that. On yours, it should just come centered in the screen. Unresizable, and it should be 800 by 600. Everybody get that to work? Give me a green circle if you've got that working. You guys are good. Or you're fooling me. Okay, next thing we want to do. We want to add some content to the screen where we could draw a picture, for example. Or we could put components if we were building a user interface. We're going to use this mostly for, at least initially, for being able to have a place to draw things. So what we're going to do is, first of all, we're going to change the set size to simply say pack. That means whatever we put into the J frame, we're going to use its size and we're going to pack as tightly as we can around it so that if it changes size, so will our window. We don't have to worry about it as being a J frame. So, what I'm going to do here is I'm going to say JPanel, JP, is equal to the new my JPanel. Then we're going to say JF.add JP, comma, border layout dot center. And you'll have an error because we haven't written this class yet. You can do a Control-Shift-O to bring in JPanel's header though. Okay, let's drop down below Maine. What's below Maine? Connecticut? I don't know, something. Okay, now, we're going to create an internal class here to handle the drawing thing that we're going to be working on. We're going to take a JPanel, which is intended to hold other items, but we're going to turn it into a drawing surface because a lot of the methods and things that it has built in it are methods we'd have to write otherwise. So what we're going to do is we're going to say static class myJPanel extends JPanel and open and close the curly braces. Now, if you go back up, this guy should not have an error anymore. And you should be able to run this. You run it again, we're going to get one of those little winky-dink window things. One of those, because we haven't given it any size yet. We do have, although you may have trouble seeing it, a little tiny yellow line underneath my JPanel. You hover over it, it'll give you some choices. What we want to do is add the default serial version ID. You get this really ugly line with some comments on it. Get rid of the comments and just make that be the first line in your class. That's used if you ever want to serialize your classes to disk. So if you've configured them in some special way, you can restore them. But it gives it a version ID, so you can't have changed members around and have it, reasonably try to reinitialize the thing. So we won't use it for anything, but it gets rid of a warning message. Okay, now let's add a constructor. What I normally do, and you'll see some of my spacing as we go along, I usually separate that from the constructor. And I'll put other static or other private members up there when we need them. So let's create a constructor from my JPanel. First thing we want to do is we want to do a set layout to null. And we want to set the background color. Just say set background. I'm sorry, that's an error on that part as I recall. And in the parentheses, let's make it colored yellow. Make yellow be all caps, even though the system's going to want to make it lowercase, make them all caps. That's proper Java for a constant. So we've said, we will take care of all the layout. We want the default background color unless we paint something else. We want it just to default the yellow. And let's set our preferred size. Be a new dimension. Let's make it 800 by 600. Control-Shift-O to bring in any headers that are missing. And let's hit run. Did you get a lovely yellow window? Give me a green circle if you have a lovely yellow window. And lovely applies to ugly yellow windows also. Now, in order to draw on that window, one of the things we need to do is we need to override one of the methods. So after the constructor, put in a blank line, and then we're going to put a annotation of @override. And the method we're going to override is a protected method. Returns void. It's called paint component. And it takes a graphics as a parameter. We'll call it G, and we'll curly brace it. Control-Shift-O to bring in any headers that are missing. Now, hit run. Look at your pretty yellow window. Mine looks like it got washed too many times. How about yours? Did you get a gray window? You're doing things right if you got a gray window. Anybody want to make a proposal of why that is not yellow? Raise your hand if you think you know. So yeah,
Because I'm going to guess that the JPanel class uses paint component to paint the thing. So since you overrided paint component, it's not using the one and set background anymore.
yeah. Turns out it's a little more complicated than that, but that's pretty close. When we set override, we're replacing any calls to paint component. It turns out that we don't paint component. We're not the guy that paints the background, but our parent does. So we need to include a line in here that says super, that's our parent, a paint component, and pass it up to G. Now if we run that, our beautiful yellow is back. Okay, now, up here where it says color yellow, I want you to replace that with new color, and then in parentheses, I want you to put three numbers where the values of the numbers are from 0 to 255, and the first one represents the amount of red you want. I'm going to put 128. Second one's the amount of green. I think I want 240. And the last one's the amount of blue. I don't want any. And rerun. Look at that beautiful green. Looks a little like slime. So play around for a second. Pick some numbers there that make you happy. Or if you like to be sad, pick some numbers that make you sad. So it's RGB, red first, green second, blue last. We know red and green combined together make yellow. Green and blue combined together make cyan. Blue and red together make a violet or purplish color. Mix all three together, you can get other flavors. Give me a green circle when you think you have a color. Now be honest, somebody went for just red. Somebody put 255.00, I guarantee it. Anybody want to admit to being that person? Devin, are you doing the admitting or do you have a question?
Yeah, it was me.
Okay, well, that's it's a valid color and no reason not to use it. Okay, let us move ahead a bit here. When we draw, one of the things we want to always do after we've called our parent is we want to get the proper graphics installed around us. To do that, we're going to say graphics 2D, we're going to call it G2D, is equal to cast to the G dot create. And then Control-Shift-O should bring in what you need. Now, in the original Java, way back, you were literally passed an object of type graphics. In more modern Java, this actually got replaced, and what you're really getting is this thing called graphics 2D. You have to know that it's safe to cast this thing. This creates a copy of the graphics, but we know it really is a graphics 2D. So in this one case, it's safe to cast it. So this variable is of type graphics 2D, which give us a lot better modern methods to work with. But having done that, the last line of our method now needs to say g2d.dispose. Okay, now that we have our graphics, one of the things we need to do is, just for convenience, we need to move the center of the coordinate system so that it is in the middle of the screen. What we'd really like to have here's our screen. We'd like for 0, 0 to be in the middle of the screen. We'd like x to get positive in that direction. We'd like for x to get negative in that direction. Y should be plus going up. Y should be negative going down. We also ultimately would want things to rotate, just like a coordinate system does in geometry, counterclockwise. However, initially the graphics begin with 0, 0 right in the top left corner. And worse than that, y gets positive going downward. So what we have to do is we have to get the coordinate system over here. To do that, we're going to do a little transformation. We're going to use something called an affine transform. Can't believe I remember all this stuff. To make this happen. To do that, we say affine transform we're going to call it GAT because we're going to do an affine transform on the graphics. And it's going to be equal to a new affine transform, which basically is an identity operator, meaning if you apply it, nothing happens. Control-Shift-O to bring in the header. Now, ultimately what I'm going to say is I'm going to say g2d.transform using GAT. So I'm going to take the graphics that's here and I'm going to transform it using whatever modifications we make to the transform. This is a big matrix multiplication. So in between those two, I need to put what I want to have happen. The first thing I want to have happen is I want to cause the scale to be affected. So what I'm going to say is GAT, not G2D, but GAT dot scale. I want X to be the same as it is, and I want Y to reverse directions. So by using the scale to do that, I simply am going to be multiplying it times whether it gets bigger or smaller, but by reversing the sign, I cause Y to go in the other direction. Now these transforms are a little bit odd. They're not really if you have your matrix math down, but they actually seem to work in opposite direction you ask them to do something. The first thing to happen is the last thing I tell it to do. So the second thing I want it to have happen is I want to say GAT.translate. And where I want it to translate to is I want to get the width divided by 2, use 2.0, and I want to get the height and divide it by 2.0. See what I'm doing there? In order to translate it, I have to add to where it was in the top left corner, half the width and half the height, and Y will be in the correct direction now. Now, just for sanity, hit the run button, make sure we don't get any terrible errors. Nothing new should happen. You just basically have your screen. Close it when you're done. Now what we'd like to do is let's put something on the screen. So what I want to do is let's put an ellipse on the screen. There's a whole set of geometric shapes and things which we will use, and there's a whole bunch we won't use. We're going to use the ones that seem to have the extra either dot double or dot float on them. They'll usually end in 2D. So to create an ellipse, I need to give a box for it to live in. So I'm going to say ellipse E2D is equal to the new ellipse dot double. And I'm going to break it open so that we can put the parameters on separate lines. First parameter is where is the X position? I'm going to say minus 100. Where is the Y position? Minus 100. What's the width? 200. What's the height? 200. And it will properly put an ellipse inside of that box. Control-Shift-O to bring in the header. Creating it doesn't put it on the screen, however. Oh, I'd actually spelled this wrong. It's ellipse 2D. In both those cases. I told you I'd make some mistakes for you. Now, we're going to put some code in and we're going to modify it a little as we go. So you kind of pay attention or jot down notes, whatever you need to kind of remember what we're doing here. What I'm going to do is I'm going to create an affine transform, another one. Oh, this one AT because it's going to be the one that's the main transform. The new affine transform. And I'm going to have it do nothing to start with. But what I'm going to do next is I'm going to create a shape called S, which is equal to, use that transform, create a transformed shape. And which shape am I going to transform? E2D. Now, what we need to do is we need to put it on the screen. So what we're going to do first of all is draw the background color. Then we're going to come back and stroke around the edge so that we get an outline on it. To draw the background color, what I need first of all is I need to take my graphics and call set paint and pass set paint a color. And this color can be any color you choose, but make sure it's one that will stand out against the background you picked earlier. So I'm going to, what I'm going to actually do is I'm going to just say color dot white. And I'm actually going to go up to where my other one was, and I'm going to put this back to color dot yellow. You can be much more creative with your colors. So once I set the paint, I need to say G2D.fill and give the thing that I want to fill, which is S. So go ahead and run that. Should get a nice white background object in the center of your color-filled area. Now, if you made it too close to the other color, you won't see it. feel like I'm getting a sunburn out of mine right here. Now, the next thing we want to do is we want to draw around the edge. So there's two things we need to do. First one is we need to set the size of the line. Where's G? I do a set stroke, and we're going to call a new basic stroke. Pass it a number. I'm going to use the number 3.0. It has to be floating point, so we need a little F. So Shift O. Now I'm going to set another color. This should contrast with both the other two. So set paint. I'm going to use color.black because I'm not very creative. And then just go around. Oops, see, it wants to put it back to lowercase on me all the time. Don't want lowercase. P2D dot draw. So we fill first, draw second. So hit go. We should get something that looks like this. Give me a green circle if you have something that's pretty much in line with what we've been working on. Okay, now, the objects, if we go to the documentation, like ellipse and all that, oops. Ellipse 2D are in a package called java.awt.geom, geometry. So if I go here and I go to that package itself, if I can get there from here. You'll find the drawing things we need. The ones we're going to be interested in are the ones that have a 2D in them. So for example, we probably won't use area. We probably won't use flattening path iterator or general path, illegal path statement, these things. We want to use the ones. So if I ask you to draw something for me, tend toward these. The one called Path 2D is one that you're going to want to pay particular attention to. Make some note about that because it's a way of kind of scripting the others into a single path. So you only have to draw this path and you get lots of shapes out. There'll be some things down here that sound tempting, like rectangular shape. They're the base of rectangle 2D, for example. Rectangular shape, for example, we look at what extends it. It has round rectangle 2D, the ellipse, the arc. These are all usable. This by itself is probably one you want to stay away from. But just be aware, particularly of that path 2D as being a hint that it might be something you'd like to have in your future. Now, we know how to draw, and we can get something on the screen that, I mean, that's one of the snappiest looking ellipses I ever saw. Let's assume that what I would also like to be able to do would be to cause the thing to change over time. What I'd need to be able to do is now this one I need notes for, so let me see if I have my notes here anywhere. I do not be in that set. Let me look over here for just a second. Okay, I think I found it. Where did I put it? Okay, I must not have properly gotten it. What we want to do is we want to be able to draw, but we want the screen to call draw automatically for us. So we basically can, can't believe I didn't save a copy of that. Nope. Did not. Okay, well, it's not critical that we do that. Oh, wait a minute, this may be good enough to do it. Let's add this to the code. Inside our constructor for the J-frame, after the set preferred time, let's create a new timer and do it 1000 divided by capital FPS, which stands for frames per second. And we're going to give it an AE arrow repaint. Close the parenthesis one more time, and then do dot start. Now, FPS has not been defined, so what we'll do is, right below this version ID, let's do a private int FPS be equal to, let's make it for now 30 for 30 frames a second. So hit Control-Shift-O, and it's going to ask you which timer do you want. You want the one that's in swing, Java X swing timer. So we create a timer, scheduled to go off, divide the 1 second that's in milliseconds by 30 frames. That's going to interrupt us that often. And what's it going to do when it interrupts it? It's going to call repaint. We start the timer, so initially it'll start repainting immediately. Now, if we were going to change our display, we would do something with this affine transform in between here. So I'm going to just put in here for a moment that what we want to do is at dot scale. And, well, I would need some parameters sitting outside to make this work easily. I think, do I have an easy way to write this code for you? So teach me to do this without looking at notes. What we would need to do is have these variables somewhere stored inside the method. So inside a paint component, right after the super, I'm just going to create, this is fake code for now. I'm going to go on index, or integer scale x is equal to 1.0. Actually, it shouldn't be integer, it should be a double. And the same thing for scale y. Not 5y. And then down here inside the parentheses, where did we do our transform? Right here. What we're going to do is we're going to say scale x comma scale y. That's what I called them. And then we're just going to say scale x plus equals 0.1. Scale y plus 0.1. Okay. Now I'm going to put off to the right-hand side here. It's a comment marker. That just says these lines were written without thinking about them. If you were to have to write those, you'd have to think about them. Same thing up here with this, these two lines. They're not part of your normal model. Now, there's one other thing we need to do. Now, the very last, right before we do the dispose, we need to say toolkit get default toolkit dot sync. And that fixes a bug in Mac and Linux, but you should nevertheless do it for Windows anyway. Now, if we look at our thing that's running here, we can't tell whether or not it's actually being called and doing it, other than we can see that our thing is not bumping up, by some percentage on this. So very likely that made a mistake. I'm going to type a couple of lines here that you don't need to type. I'm just going to see if we're in the method. I may have to give you more data than that. Now we're being called. It's just our update code is not. Oh, you know why? Oh, I know why. Does anybody know why? I know why. I did something wrong. What I did wrong is I put these inside of the method that gets called for repaint. So if I take those and I hoist them up here near frames per second somewhere, probably want to make them private, but we'll leave that alone for now. And I run. I can't get it over to your screen fast enough, so let me come down here and change these to be 0.01. Run 10 times as slow. Now your screen should be doing that. Of course, we didn't tell it to stop, so eventually it'll just turn the whole screen and get bigger and bigger and bigger and probably eat up the cat or something when it gets too big. Okay, using this code as a base, I want you to basically do one of three things, or you can do all three. I want you to draw me a star. Looks like that. You'd be wise to take a screenshot of that and save it so that you get the right size. You notice that the lines are straight, that they're evenly spaced, that the point goes up, it doesn't go to the side. It should look exactly like mine. You can do that for your homework. That's one of the assignments. You can do that, and then you can further extend it if you like. To do this. That's assignment level 2. Of course, I'd expect you to fix prettier colors than I've got. Pick something that's pretty. And based on what we got through tonight, those of you that are truly the brave ones, let's make it do this. You can turn it. Well, I'm done. I will collect it at the start of class. Don't plan on turning it in before class. If I want anything, I'll tell you what I want at the start of class. Also, don't copy somebody else's work. You can talk to other people about it. Just don't share code. If I wrote the code, you can share it, but don't share anything and don't tell somebody exactly what to do. Let them do it. They're not getting punished at this point for not being able to program. They need to learn how, not to just totally depend on somebody else. So you got choice 1, which was the simple star. I don't know what happened to it. Twinkle, twinkle, where'd you go? There's 2. You got this guy. Or you could do this guy. Or you could do that guy. Any of those 3. If you noticed in my Eclipse, there's 2 other variations that I'm not going to show you right now. They may show up on a test or a quiz, depending on how far you get on this. Anybody have any questions or closing remarks?
How accurate does the size of the star have to be to what you showed there? Like,
Well, that's why I said take a screenshot.
okay. Thanks.
They don't have to be pixel perfect, but make it reasonable. Do you have any question?
Yeah, can you show the new timer again?
Which one?
New timer?
Yeah. I can find my Eclipse again. Where was that? That was right here. Anybody else have any questions?
Professor, I have a question. I
Uh-huh.
have most of the lines of code that we wrote here, but I'm missing like a few of them. You said you were going to post this, right?
Yeah.
Okay, cool. Thank you.
Look under lessons tomorrow. I'll probably post it later tonight, but mine will do what it just did, which it'll basically be the growing circle. And you can take it that. You taking notes and writing it the first time or even writing it the second time will help you remember, because you're not going to have my code of some particular problem when you get to a test or a quiz. So yeah, you have a comment, question?
Should we make a new class within the package?
What I did is I created a new package called edumcccc.cos210.star. And then I just created it and called it star.java. And you can, star.java is fine. Or you can stick a number on it if you want.
Okay.
If you do all 3 of them, then call one, star 1, star 2, and star 3. Depending on which ones you did. Any other questions or comments? You guys had a good class tonight. I hope we did a lot of material. It's a lot of programming for me to have to do without any notes. Next time I'm going to bring my notes along and cheat. Do you have any other question, or is your hand just still up?
No, sorry.
That's okay. Okay, then, I guess you guys are ready for the world. Make sure you take a good close look at what we did in that array class. Next time, we're going to talk about the singly linked list. and we'll develop an interface for that. We'll implement it and do some testing. You might want to write some tests for your array class, just to make sure that you did it. If you didn't watch that video that I assigned you on orders, make sure you do that as well. You can get the URL from somebody in the class. You all have a nice weekend, and I'll either see you, some of you have in class tomorrow, I think, but the rest of you I'll see you on Monday. Have a nice weekend.
Thank you, Professor. Have a
Thank
good
you,
day.
Professor. Have a nice weekend.
Bye-bye.
Thank you.